Hi, everyone. Welcome. My name is Amitai Richman from K2View, and with me today is Daniel Howard from Bloor Research. Daniel, could you please introduce yourself, please?
Thanks, Amitai. Hi, everyone. Happy to be here today. I'm Daniel Howard. I'm a senior analyst at Bloor Research, as Amitai has kindly mentioned. I'm been working in the analyst space for close to a decade now, covering all sorts of different data and testing areas, which has always put me in a particularly good position to talk about test data management, which is going to be the topic of our talk today.
Yeah, thanks for being here today, Daniel. I've been following your research over the years, and I appreciate your deep dives into test data management, into data masking, PI discovery, synthetic data. All of this is really up my alley, and I really appreciate it. This is my focus here at K2View. So I want to welcome everyone here in the audience who are joining us live. And I want to just point out a few things of items for housekeeping. So first of all, we have some downloadable assets, which you can see if you click on the paperclip on the right of your screen. You'll see an attachments button. So you can go over there to the attachments and download multiple different assets. I'll talk about those in the end. Soon we're going to have a poll also to get your opinion. So please, uh, when it's time for the poll, go ahead and let us know, share your thoughts on the subject. And you can find that poll by clicking on the poll button. And above that, there's a question mark button, which you can send questions to us. If you want either myself, Amitai, or Daniel to answer specifically, please call that out in the question, and we'll get to as many answers as we can at the end of the session. So without further ado, I'd like you, please, Daniel, just to not just introduce yourself, but also introduce Bloor Research.
Sure. As I've said, I've been at Bloor for the best part of 10 years. Bloor Research is an analyst company, and we work to provide, as the slide says, impartial, independent, expert opinions to help vendors and customers navigate today's technology landscape. Indeed, technology landscapes, including, in my case, all manner of data spaces, not least including test data management.
Excellent. And now I'll introduce K2View for those of you who may not be familiar with K2View. K2View is a data product platform serving enterprises around the world in various industries with operational use cases. And so we offer various solutions like the test data management suite. We're able to integrate with all kinds of different data sources, pretty much any data source out there. And so, as I said, we're serving financial services companies, healthcare, media, retail, all kinds of companies. And we are covered, our tools are covered by various analysts, including Bloor. Thank you, Daniel, for joining us here. And so that's a few words about K2View. Today, we're going to talk about the challenge of multi-source test data. So test data can be very bare bones, or it could be very rich. And we're going to talk about the challenge of rich test data and how to get there, how to achieve it. So when it comes to tooling, Daniel's going to break down the different technological approaches to test data management, what you should look for in a test data management tool. We're going to discuss together the differences of the different tools, the different vendors out there, and how the underlying technological approach can be very different. And because of the differences in the underlying technology, the way they solve these problems is very different. We're going to talk about AI and test data management. AI is, of course, everywhere. Everywhere it's pervasive. Anywhere you look on any platform, everybody's talking about AI. Um, my opinion is that AI is making strides into test data management. It's not everywhere yet. We're going to talk about where it is and where it isn't, and then we'll close with some takeaways and your questions. So I want to kick things off by giving a very common scenario to highlight why having rich, robust, secure test data is a necessity. So if for example, you're in a QA team in a financial services company like a bank or insurance company or a payment processor. So let's say you're testing an AI-powered fraud detection model. Now, in order to do fraud detection, you need to look at a lot of transactions. The software needs to look at a lot of transactions, and the machine learning needs to have a lot of data. Now, it's not just any data, but the transaction data needs to include information about customers, needs to look at accounts and payments, and all of this data comes from various different sources, like the core banking or card processing or the CRM. Not or, it's actually, and all of these sources need to be, the data needs to be extracted from each of these sources in order to present a complete picture. Now, doing this manually can be a nightmare, and even the tooling can struggle to maintain referential integrity for that. So today we're going to talk about how we solve that problem, how we can, what kind of tools can produce that kind of rich blended test data so that you can test software. So Daniel, could you please take it away and tell us about it?
Mm-hmm. Sure, thanks, Amitai. So my job here as a resident analyst is to sort of set the stage for what Amitai wants to say about some of this multi-source complexity. And to start off with, I thought I'd talk about the most important features to look for in test data management. Obviously, these are not the only things you might want to look for. There are a whole range of different features and qualities that you might need or care for, but I think these are the most generally important in the test data management space. First of all, there's a matter of how you're going to get access to your test data. There are really two major components here. One is, as we've been talking about, multi-source. Obviously, in a multi-source scenario, you need to be able to have whatever test data management tool you're using access a variety of different sources, ideally then collate information from all of them in order to create or deliver your test data sets. And you're also going to want it to fit into some sort of continuous, ideally automated pipeline, as in continuous integration, continuous deployment, so that your testers always have access to up-to-date, fresh, and appropriate test data. Secondly, unless you're relying solely on synthetic data, which I'll be talking a bit more about later, you're going to need data privacy and compliance tooling as part of your test data management solution. This is because you're going to have sensitive data in your production data, which is going to then come through into your test data. And you need a way of finding and protecting it in order to be compliant with various privacy regulations, GDPR, CCPA, LGPD, all of the others, and so on. And for that, you need discovery and masking. And as with many of these things, theoretically, this could come from an outside tool. You could invest in a test data management solution, some sort of third-party discovery and masking solution, and so on. But it's typically more efficient to have it all in one place, such as it is. Although, if you do have discovery tools, masking tools for other, you'll probably also want discovery and masking tools for other parts of your system. So, whatever supplier for your test data management tool in this regard you may also want them to be able to cover that, or at least if you have different tools, you may want them to integrate. Although, I generally recommend one comprehensive tool which can cover test data management than trying to use multiple at the same time. The third quality I wanted to talk about was, funnily enough, data quality, as well as data realism. This is the idea that you don't just want test data to be sort of haphazard or random or incomplete. You need test data that is going to generate good tests, which is going to accurately represent your production data, but is going to test at least all the likely scenarios, if not all of the possible scenarios. And to do that, you're going to need either some way of taking a representative subset, since it's typically inefficient to throw around entire production data sets, while maintaining referential integrity, so those subsets don't sort of fall apart under any sort of scrutiny and so on. Or some way of generating synthetic data. Actually, that shouldn't be an and/or, because synthetic data can often be used to supplement incomplete data in order to create more accurate, more thorough testing scenarios. So that's, yeah, another point there. Amitai, you sound like you have something to say.
Yeah, I want to comment on the term subsetting because different vendors use the word subsetting differently. Some vendors use the word subsetting to mean a slimmed down version of the production data set. So say 5% of the data of the original. So I don't know, let's say it's a terabyte of data as the original data set. So they'll give you or will give you a 5% version of that overall data set, which is of course a lot smaller form factor that can, much easier to handle. Another way that vendors refer to subsets is to actually specific, like one of the things we do at K2View is to pull a part of the data that's just the data that you want. So you don't want all the data. You just want, for example, specific customers in a specific geographic area that meet various parameters. For example, let's say they have a specific loyalty card or they've spent a certain amount of money. So, so just wanted to call out that when you hear vendors talk about subsetting, you need to clarify what they mean by that because it could be one of the two.
That's a great point. The level of intelligence involved in subsetting can vary significantly. As you say, some vendors will just say, right, we're going to chop out 95% of the top 95% of the data and call it good. Obviously, K2View and some other vendors do something much more clever, where they selectively picking things out to retain, as I say, this is one of the ways of retaining referential integrity. And then, the final thing I wanted to mention was when you've actually got your test data management solution up and running, how well can it cope with how well can it deliver self-service in terms of things like access to QA teams, test data reservation, test data versioning, and so on, as well as general automation, how automatically your test data management solution works once it's all set up and running and so on. As I said before about testing, is that automation is sort of a watchword. Automation means more testing. Automation means less work, less cost. It's really important, and it's really, really good to have as much of it as you possibly can. And that certainly holds true in test data management.
Yeah, and the way I think about it is whether the software has been built for testing in mind, or is it some kind of technological development that somebody realized, hey, maybe we can push this into a testing environment and call it
Sure.
test data.
Yeah.
So we're going to dive into it deeper when we see the different technological approaches. But that's something to keep in mind because a lot of vendors say, "Oh, this is test data management." But as we'll see, some of the software was built for testers to use and some not. So we'll talk about that.
Absolutely, yes. Yeah. As Amitai says, we'll perform that later, but very good point.
Yeah, thank you. Let's jump into a poll. If you click on the poll button on the top right of the screen, would appreciate if you'll answer the following question: which of the following challenges is your number one test data headache? So is it slow provisioning? So are testers waiting to get test data, and it's a real pain in the neck. Either they have to wait for it from a central team or they have to prepare it themselves. Is the biggest challenge in test data for you compliance and security risks? It's a very common or traditional practice to copy production data and put it into a lower environment, and there's a lot of concern around that. There's awareness of regulatory and privacy compliance, and you want to make sure that you can manage your risk. Is it an issue, as Daniel mentioned before, that sometimes there's test data, but the quality of the test data can be low. Not all test data is created equally. So when you have low quality test data because it's not really representative of production data, then that could be a big concern. Or if you're a DevOps oriented automation type company where you're automating your software development, but the test data is still being done manually, Is that your biggest issue for test data? So I see people answering. That's great. Let's continue the conversation, Daniel, and we'll come back and look at the poll results in a bit.
Sure, sounds good.
Okay, go ahead, Daniel.
Thanks. So yes, following on from what I was talking about before, I wanted to talk a bit about the different approaches, various that you can take to test data management. And I should say up front, it's entirely possible to use, and in fact fairly common to use several of these, or at least multiple of these at once, possibly with some exceptions. But in general, what we see, what Bloor sees in the market, is people tend to pick one of these as sort of the central pillar for their approach, and then maybe give themselves access to some of the others for when their main focus is no longer appropriate. Because as we'll see, these all have situations where they're less than ideal. But I'm going to talk about them individually because, again, this is how most people deploy these solutions and how most vendors offer them. First of all, right at the top, there's manual testing, which is not something vendors really offer in the same sense as the others because it's not really a technology in the same way. This is something I'm sure you're all familiar with on some level, in which essentially you are manually writing tests, you are handing it over to people to manually run through. It's all extremely manual, extremely slow, and extremely labor intensive. And to top it all off, it produces very low quality test data. It's very prone to things like bias. It's very easy for if you imagine a manual tester is going through hundreds of these rote repetitive tests in a single day. It's very easy for someone to make a mistake, make an error. So they're not very consistent because they're so slow and difficult. It takes so much time. They can be very expensive if you do anything at scale because you have to hire so many manual testers. Of all the methods on this slide, manual testing is the only one I think I would unequivocally never recommend to probably any circumstance. I've certainly not come across one yet where I'd say, right, manual testing, that's the one for you. So I think this is best avoided. Unfortunately, it is also certainly the most entrenched method of test data management today. A lot of organizations simply rely on it and have done for a long time and haven't made the move to anything else, which I would very much recommend you do almost regardless of which method you decide to adopt, because they're all going to be a massive improvement on, as I say, manual testing. But sort of moving, this isn't, I don't want to say one step up from manual testing because this is not hierarchical on the slides, but certainly more advanced manual testing is centralized provisioning. This is essentially using subsetting to create a single centralized test data repository, which you then can sort of allow, you can then deliver test data from that repository to your testing teams. And this is generally fine. You're going to have to use subsetting for this because otherwise you're going to end up with it's simply too computationally expensive to move entire production databases around for people to test. It becomes too unwieldy very, very quickly. But on the other hand, when you end up with this single monolithic centralized test data repository, that can be very difficult to maintain in and of itself. It can be quite difficult to use, especially if you're not in data or in IT, which means if, for example, if you're in QA, you need access to some test data, it can be quite a pain. I think when Amitai was talking before about solutions which were not designed with test data in mind, these are often some of the main culprits, where they've spun up as these big data solutions which have said, okay, right, we can do test data as well. But again, we'll get onto that in a moment. Past that, or just below that on the slide, is data virtualization. This is a technique where you do get to test with entire production databases, sort of, because what you do is you create virtual databases, which are effectively ways of passing around all of the data in a production database, but virtually. So you're not actually moving it around, you're just allowing test data to your testers to access all of that data in a reasonably efficient way. And this is great for, if you want to give everybody a personalized production database to test with, great. And if you want to quickly spin up test environments, also very good. On the other hand, there are some very serious cons to trying to test with entire production databases, even past the amount of, even if you get rid of the efficiency issue. It's just a lot to handle, for one thing. It's very hard for testers to get their grips on an entire production database, especially in a large organization. And for that matter, it can lead to a lot of over-testing, where you are essentially testing over and over again the same thing. You've got a lot of redundant tests involved, because you think about it, your production database, probably 90% of the data scenarios in there are going to be the same, at least similar, if not completely the same. So you don't do it running a lot of tests you don't really need, and that can be quite inefficient in and of itself. There are also more technical issues, which we'll get onto in a moment when we talk about vendors. Amitai, do you want to chip in here?
No, actually, I wanted to, everything I think is all clear, but as we get to the rule-based, if you don't mind also explaining the difference between the rule-based and the AI-based synthetic data.
Of course, yes. So,
thanks.
As Amitai was saying, next on the chopping block is synthetic data, and we've split it into two types here, which I think is not something which is done, but I think it's important to do, at least in this case, because they're quite increasingly. I think there's a gap in the market between these two. So synthetic data in general is the idea of creating fake data sets. So rather than having a production data set or a subset of it, you have a completely fake data set you've created, in principle, at least somewhat based on your production data. And there's two main ways of doing this, I should say. There's rule-based synthetic data. This is essentially where you set up a series of generative rules saying, I want to create X number of rows with these columns with values taking place, from this set. So I want a first name taken from this list of names. I want a last name from the same. I want age, random number between 18 and 67, whatever. You create all of these rules, and then they generate a synthetic data set for you. And this is one of those technologies which, once it's all up and running, it's great, at least until you need to do some maintenance on it. But the actual process of setting up all of these rules in the first place is very time-consuming and laborious. And you need to have a very in-depth understanding of what you need, or you're going to create something which is not actually appropriate. And as I say, when it comes time, you then have to continually maintain that as your production data evolves. You need more test data and so on. So it's a lot to handle.
Yeah, and it's very, very difficult to mimic production. The production data is usually very, very, varied and rich and very, just imagine, a population as different people, different ages. And even though you try to set things up with rules so that there's variety, it never really looks like a real data set, a real production data set would.
Yeah, absolutely. You would have to. I've sort of hedged a little on the slides I've made here, because theoretically, yes, someone who was outstandingly good working with a relatively small, a relatively narrow selection of data could theoretically make something which was really representative. But in practice, that's just not going to happen. Because data is too complicated, production database is too complicated. You're normally not working with tiny scenarios, working with massive ones. The real advantage here, I think, which is, in some sense, its core selling point, is that it allows you to create test data sets without any access to production data. Which, again, I'll talk about this in a bit later, but if you've got a completely greenfield project, you've got no production data, whatever, it can be very useful to have this capability to create something, even if it's something you're likely to transition out of once you actually launch and you get some real production data going.
Exactly. And the example I like to give to explain that is, for example, let's say a banking application is now introducing the ability to transact in cryptocurrency while until now it was only, US dollars and euro and the traditional currencies. So that there isn't any data of customers transacting in Bitcoin, for example, because it hasn't been rolled out yet.
Mhm.
So when you're developing, the developers are developing apps. They're creating the tables and the fields for the crypto. But then how do the testers actually test it without actual test data? And that's where you can create some rule-based synthetic data to do that job.
Yeah, and I think what I sort of said at the top of this slide about how it is often useful to have access to multiple of these methodologies. I think this is a prime example of that, where you would I think it's very rare that you would want to have this sort of method as your primary means of creating test data, but as a supplementary means, as I say, in greenfield scenarios, or if, for example, there's a very specific scenario you decide you must test, and you can just create some synthetic data built around it, that has some real application.
Yeah, I think that's an incredibly important point. I think it's worth even just repeating it, because a lot of people, let's say they go into Google and they look for test data management or test data
Mhm.
management tools, and all kinds of vendors come up, and each of these vendors will fall into one of these buckets that we've set up here. They won't necessarily tell you that. You'll need to really do some research to understand what the underlying technology there is,
Mhm.
and that's what we're coming to in this session to uncover and reveal. Actually, the underlying technological approach will dictate what the tool can actually do, whether
Yeah,
they're built for
absolutely.
testers. And a lot of these vendors call themselves. So if you just look at it superficially, you can list 5 or 10 different vendors that are a test data management tool, and you can make an Excel sheet and look very, okay, this one, and this one. But actually, if a tool just does one of those things, like rule-based synthetic data generation, then that's great for some scenarios, but it's not good for others. And you need to really be cognizant of that fact. Anyway, please carry on, Daniel. Thank you.
Yeah, no worries, actually. And yeah, but finally, talking about AI-based synthetic data. So this is, again, it's a synthetic data. So again, it's fake, which means, as with rule-based synthetic data, which perhaps I didn't make enough of this, there's no possibility of sensitive data creeping in. So you don't necessarily need you don't need to run discovery facilities and so on with this kind of data. In this case, rather than using rules to create it, you're using some sort of AI-driven analysis. So unlike rules-based data, this does require production data to exist to begin with. And essentially how it works is you point some sort of analysis tool, usually AI-driven, usually machine learning, at this production data. And if the tool's well built, it will analyze this production data set, identify the statistical distributions, the patterns of data present within it, and then create new data, which, while each individual piece of data is completely fake, the data set as a whole contains the same, what's sometimes called the statistical integrity of the original production data. And if done well, that's a load-bearing remark, so we'll come back to it. This is really good for because it automatically creates compliant test data because there's no sensitive data in there, which is representative of your production data. So unlike rules-based, it's not, it's not fake. It looks like real data, and it feels like real data, which is obviously very good. The caveat here is if it's done well, which is quite hard to do. And to top it all off, you also then end up with very little sort of control over how your test data turns out. Because, I mean, I suppose theoretically you could take your production data set and try to sort of replicate it and chop it around and try to influence the result. That's obviously going to be very, very hard to do. In practice, you're getting whatever your model spits out, and so it can be quite volatile in that respect. I do think it's something a lot to be said for this method, but it's not something you want to use by itself.
Yeah, and I want to be conscious of time, as we have about 15 minutes left, and I just want to reference the poll. So most of you out there said that compliance and security risks are the biggest concern as it comes to test data management, and that's no surprise to me. That's something that we hear from our customers and people we talk to in the market all the time. So please continue, Daniel. Thank you.
Yes. Thank you, Amitai. Thank you for the time check. I know I've been getting on. So what I want to do now is, in reference to these approaches we've just discussed, I want to talk a bit about some of the major sort of collections of vendors which are present in the market today for test data management. The first of which are the legacy players. These are people like Informatica and IBM, Broadcom, who primarily use a centralized provisioning approach we've just discussed, which is usually reliant on subsetting. Those vendors, I don't think any of those vendors exclusively rely on subsetting for test data management, but that's certainly the primary method they tend to employ. And obviously the good thing here is these companies are big, they have big offerings which do a lot of things. They've been around for a long time. They work, they offer this single sort of centralized repository of test data. And obviously you have these big platforms which offer lots of different capabilities.
Yeah.
On the other hand, sorry, go ahead.
Sorry, and I want to add there also that they launched these products in 2008 and 2009, so they were really pioneering this industry. And they built these products for testers. So it's not listed here, but one of the pros that I would add here verbally is that they are built for testers. You mentioned subsetting. They usually offer data reservation so that testers can have their own test data set and not trample other people's data. They usually offer versioning so that you can, if you made a mistake, you can roll back the test data and not have to start all the test again. So on the positive side, these guys have built tools for testers, and they've been battle tested.
Yeah, absolutely. These are, I mean, if you're looking for something which is reliable, these have been in market for the longest time. All vendors we're talking about. On the other hand, they are also, because they're so mature and have been built up over time and have so many different pieces of functionality, they can be very complex. Even for testers, they can be very difficult and complex to use. Of course, also being the largest vendors, they're also very expensive. There can also be difficulties with vendor lock-in and incompatibility. For example, if you're looking for a test data management solution, but you've got a lot of other data solutions in place, buying someone like Informatica is very expensive enough. Unless you're buying the whole suite and bringing them in to do a lot of your data things for you, you can't just buy test data management from Informatica, right? It's not practical. When you're paying that much money, you need to do everything. It can't really slot into a solution, in a piecemeal way that you might want to from you might get from a solution with smaller in scope. And finally, they're also reliant on creating, not entirely, because again, the vendors I've talked about all offer some other sort of capability, but in general, they're reliant on creating representative subsets.
Yes, and while they are built with testers in mind, the operators of this software is usually centralized platform team, right? Many of these tools require SQL knowledge. It requires understanding the data and the sources. This is normally being used by data engineers and IT people. This is not software that is very easy to use. So when they say it's self-service, it means that it's not a command line interface. It means that it's software that there's a user interface for the IT team to use, for example, or the data engineers.
Yes. I mean, sometimes you'll have a very high level interface to use, but if you want to get into any level of detail, you're going to need to have some technical knowledge. Self-service is not the watchword for these companies. So second, I wanted to talk more about database virtualization, which we've already discussed fairly at length. So I just want to talk about the sort of status of the vendors in the space. And this is a bit of an odd one because there's one 10-ton gorilla in the space, and that's Delphix. Now Perforce Delphix, they were acquired, I think, last year. And then sort of a grip of sort of smaller, not necessarily startups, but certainly smaller vendors offering less generally smaller in scope capability. And the pros of these are all that you get to use database virtualization, which has its own advantages, as we've already discussed. Which also, of course, has its own cons, again, as we've already discussed. Particularly for things we mentioned before, these vendors often have limited compatibility. There's an inherent inability to mix real and virtual data, which can come up. And there's also some of the things we've sort of heard sporadically is that database virtualization can cause some friction with a lot of common cloud payment models. Because of a whole moving, theoretically you're moving a whole database around, but actually you're not because it's virtualized and so on. But that's not always recognized in these payment models and so on, which can cause a lot of expense. But in terms of the vendor situation, Delphix itself is infamously, or has always started the highest revenue companies because it is itself very expensive. While other vendors, smaller, more limited in scope, often lacking certain features, lacking self-service models, things like that, are often designed to be, or are limited in very limited in compatibility, for example, but often designed to be more supplementary. And finally, I want to talk a bit more about synthetic data. I'm not going to sort of go over this because again, we've talked a lot about why synthetic data is good, both in terms of rule-based and AI-based. But just to point out that yes, there are quite a lot of synthetic data startups, and even getting into sort of SMEs. A lot of them, I think, by far the majority, use rule-based synthetic data, which, as I've said, is fine as a supplementary tool, but would never recommend as a primary method. And then a relatively small number of vendors will actually offer AI-based synthetic data, which I think is significantly more worthwhile an investment. Anyway, I think that's what I wanted to say to set the stage for Amitai. So I'll pass back to you.
Thank you, Daniel. Yeah, we're gonna circle back to some of these points pretty soon, but I just wanted to explain the K2View's approach to test data management because we have an approach that combines all of these technologies together, and also we have a very unique way of looking at data. So we we don't have enough time to go into it in detail now, but we have what we call a micro database, which is a compact form of, for example, a customer, so that you can move test data from production, mask it in flight into K2View, a test data repository, and then from there, testers can or developers can subset using a user interface, a web portal that we have, or APIs to subset exactly the data that they need, and the data is treated as a data product. So it's a complete set. So think about one particular customer. It has everything that the customer, everything about the customer is stored in this micro database, so that all transactions and the CRM or the data from all the different data sources is in this compact, compressed unit, which can be quickly drawn by testers. So, for example, if you need 500 customers that belong to a certain loyalty program and that live in a certain state, you can quickly get that information because of the way the data is organized. So, again, I'm not going to go into it in detail, but just to show you what our solution looks like at a very high level. So, as I mentioned, K2View can ingest data from any data source. And then we discover the sensitive data, the PII. There we have two methods of doing so, either through regular expressions, which are kind of like the rules that Daniel explained for synthetic data, but a little bit different, or using AI. We use LLMs to discover sensitive data. So the AI is able, just like ChatGPT can be used to understand what's a first name, what's a last name, even if it's in a foreign language. We mask that data, compress it to a very small footprint, and version that data so you can roll back to a previous version. So we organize that into those micro databases, the test data repository that I mentioned before. And then we can do various operations with that. We can subset the data, generate synthetic data, transform the data in various ways besides masking, for example, aging. We can reserve it for specific testers. As I mentioned, you can load the data into any environment. You can roll back, and you can access that data, as I mentioned, through self-service portal or through APIs. So now let's circle back together, Daniel, on the different pros and cons of the different technologies. So what we covered today is that we looked at the various types of test data management solutions and the underlying technology. And we saw that the underlying technology is going to drive the capabilities. So for example, let's go one by one for a moment and quickly go through an example of each. So for example, on automated PII discovery, right? So actually this is something that it is fairly prevalent and common because it's a very important part of a test data management solution. If you cannot find the sensitive data, then what is your masking actually accomplishing? If you're only masking the data that you know about, but you're actually leaving uh, PII in areas that it should not be there, then you've actually haven't accomplished what you need to accomplish. So this is something that most vendors give some attention to, but
Yeah.
it varies by vendor. And for example, the legacy TDM tools, the founders of the industry, they offer that as a separate module typically. So that's the way these the legacy vendors, they built the software in 2008 and 2009, and over time they basically added layers of software modules, if you will, which you can buy a la carte, and you can add those capabilities. So some of them offer synthetic data generation, some of them don't. Some of them offer PI discovery, some of them offer basic masking built in and more advanced masking capabilities as a separate module. So you can choose, you can pick and choose what you want. But the downside is that if you want all of those abilities, then it's going to be quite expensive. So that covers also built-in data masking. And feel free, Daniel, to jump in anytime. But I
Yeah,
just want to point. Go ahead.
I was going to add that there's a lot to. I'm doing a lot of research into sensitive data discovery at the moment, and there's a lot more to it than you might think. Coming at it from sort of, it's important to have a sophisticated way of finding sensitive data. It is not obvious what data is sensitive and what is not. Let me put it that way and stop there for time, because I can talk about this for a while.
Yeah, let's in fact get through this quickly. But something to be also very aware of is whether you want to future-proof your organization. So I'm referring to support for any data source. So this is so different vendors tend to support different databases. So almost everybody will support the popular Oracle and Postgres and various relational databases that are common in the market. But as more and more NoSQL databases come to the market and cloud becomes more of a factor, um, you have to be aware that certain technologies, for example, data virtualization, is actually quite difficult for them to develop integration with new data sources because of they need to simulate the new data source in order for this technology to work. So you want to be aware not just of what you want to connect today, but you need to think about also the future. And it's of course very important that referential integrity. If it's important that you have the complete view of a customer, for example, then you want to be careful about using tools that don't preserve referential integrity. You're generating data, for example, synthetically from different data sources, and then you've got to manually blend them together. So I'm going to push on to AI in TDM, and I'd love to hear from you, Daniel, please. Where we're at so
Sure.
far with AI.
Yeah. Again, there's a lot to say on this topic. We're pressed for time, so I will be brief. AI is already being used in test data management, and frankly, it has been for years. It's being used in classification, typically machine learning, but increasingly generative AI, which is a more recent addition to the space, as well as in data masking, because again, this is for creating the data you're going to use to mask with, to layer over your original data, and indeed in synthetic data generation. Obviously, we've talked about AI-based synthetic data generation already. You can imagine how generative AI might be playing into that. And in the future, we're expecting this to get even generative AI to be applied in even more different areas, to create smart automation, to create even more sort of adaptive data generation, not just synthetic. And indeed, agentic AI is sort of reaching its tendrils everywhere. I expect it's going to come to test data management as well. But despite all this, we always need to bear in mind that AI, and particularly generative AI, has some significant risks and limitations which you do need to bear in mind. AIs can easily become biased. AIs are very difficult to control. And there's the privacy compliance issue, which applies to LLMs and generative AI models just as it does to your test data or anything else. So you need to make sure anything which is going into or coming out of an LLM is secure. You're not incidentally feeding in sensitive data, which may then be outputted to one of your other users, or in the worst case, the public. So again, something you really must bear in mind.
Yeah, so I think different companies have different views of AI. I think
Absolutely.
there are some that are perhaps reluctant to have AI integrated into products, and some of them are actually looking to embrace the cutting edge of technology. So that's something to be on the lookout for in when you're choosing a TDM vendor to see whether they incorporate AI and how.
Mhm.
So I think that's pretty
Absolutely.
key.
Yeah, I would
Um,
typically caution a moderate approach. AI is, you don't want to be too gung ho about it because of the aforementioned risks, but also if you're not doing it at all, then you're being left behind. So,
Yeah, there's no stopping AI. I think my own personal opinion,
mm,
it is becoming more and more pervasive, and it's a question about adopting it in the right way at the right time. Um,
absolutely.
and securely, most of all. So just to wrap up, we saw today what works. So for most of, let's say for the enterprises that we work with, they seek modern tools that can pull test data and pull data from any source, mask it on the fly, and deliver it through what's truly self-service in our view is for anybody to be able to use the test data. So
Mm,
testers and developers without having to understand the underlying data sources, the data structure. They don't need to know SQL. That's how we define self-service at K2View. What can sometimes not work would be sometimes, depending on the complexity of your organization, sometimes legacy tools struggle to keep up with lots and lots of data sources with different data formats. And because of the way that it's built with module on top of module, you often have multiple UIs to handle various tests. So the way it was described to me by one customer is that we used to create this script for the TDM tool to run overnight, and then they would go home and pray in the morning that when they came back, that it wouldn't break along the way. So basically, fingers crossed. So that's
mm,
modern TDM tools should not be like that. Modern TDM tools should be able to give you that test data right away without going home praying that it's not going to break overnight. We saw also the advantages and disadvantages of synthetic data generation. At K2View, we believe that synthetic data generation is a wonderful thing. We have actually 4 different types of synthetic data generation, but we believe that there's a tool for every job, and not every tool, not every job requires the same tool. So you want to have actually a toolkit that can handle different jobs. And we talked about AI is in fact coming into TDM, maybe not with some of the legacy players, but the more modern TDM tools like K2View um, are using AI in a very productive way. And lastly, I just want to point out again that we have attachments here in if you click on the paperclip, we have some wonderful reports that you could download. So first of all, in the middle, you have Daniel's report on, in brief, on K2View test data management solution. We also have some market research that K2View commissioned through a third-party firm on the state of test data management, a very interesting read, highly recommended. And also K2View Test Data Management Tool Buyer's Guide, which goes into greater detail and covers more topics than we were able to cover today. So Dana, we're out of time, and we actually don't have time to answer questions, unfortunately. Apologies. I'll try to get back to um, people who submitted questions. And
mm.
thank you, Daniel, for joining us today. Thank you, everyone who joined us live. And I wish everybody a goodbye and look forward to seeing you at the next live session. Thank you, everyone.
Yeah. Thanks for having me here, Amitai, and thanks to everyone for coming. Take care, everyone.
Take care. Thank you. Bye-bye.